I'm Pablo Artal, and we are now at the optics lab at the University of Murcia. What we are doing here, we study the optics of the eye, and we build instruments to understand the optics and to develop new instruments to see better. The eye is a very simple optical instrument. It's just a lens forming the images of the wall on the retina. In fact, the eye is working as simply like a lens, just forming the image of the wall on a screen, and in this case, the screen is just the retina. If the eye, everything is working fine, we have perfect, very nice images, and the visual system is working very nice. But in many cases, we can have situations like we can have a longer eye, and in this case, we have a myopic eye, or we can have a shorter eye, and we have a hyperopic eye, another type of things. Perhaps you wonder sometimes how people are really seeing. Of course, you know how you are seeing, but how people are really seeing. How is your grandmother seeing? How is your neighbor that is complaining with myopic? How is doing? Well, we built an instrument, a unique instrument, what we call an adaptive optic simulator, to really predict how people are actually seeing. I'm going to give you a tour about this instrument. I'm going to present some example of how some people are actually seeing. This is our instrument. This is our adaptive optics visual simulator. The idea of this instrument that we build, all these optics, lenses, electronics, computer, is to introduce in the subject eye the optics that we want to really produce. The central elements of the instrument are these two here. This is a deformable mirror. It's a mirror that is, you can change the shape very precisely, and spatial light modulator here, liquid crystal, spatial light modulator. These two elements are optically conjugated with the eye pupil here, and they are inducing the optics we want to produce. To do this, we actually need an invisible laser being here coming to the eye, the light reflected back, going through the lenses and the mirror, and going to that sensor. This is a sensor measuring in real time the optics of the eye. The sensor is connected with the correctors, the mirror and the liquid crystal, through this computer here. All these working together produce the desired optics in a non-invasive way in the subject's eye. When the subject is looking here, he is actually seeing any type of images projected through a small screen. This is a micro display, it's a tiny screen here, and it's inducing into the system. So you can imagine that this is like a complete artificial eye that we can really model, and is connected to an actual eye. And then we can just see the world through the eyes of anybody in a non-invasive way. Well, maybe now you are curious about how different people are seeing. And I promise you that we can show to you the real cases for different people. Let's just start with myself. I'm a little bit myopic, not very much. And I'm going to show to you how I can see a car in the distance, just a 60 meters. Imagine I'm driving and I see a car in front of me and I can't read the number, or I cannot read the number. In fact, when I don't have my spectacles, I cannot see the numbers. If I correct it, I can see. And if I could have some kind of super spectacle, some kind of using this type of instrument, we can correct all the defect. We can really read the number, and it's a situation that we call like a type of supervision. So we can have a better vision than normal by correcting these aberrations. And a normal, more or less, slightly myopic, so more or less normal vision. But what's happened with your neighbor? I mentioned before your neighbor with is really myopic, highly myopic. How this person with 5 diopter myopic is seeing? So this is what it's saying. About what? About several letters. So this is the image of a person with 5 diopter of myopia. if we are correcting this myopia step by step, and this is like 4, 3, 2, 1, and somebody with everything corrected, you can see how badly the images are for this myopic person. So you can imagine, we can really simulate. I'm going to show you another example. Maybe you are familiar with your father or your grandfather, that when they are reading the newspapers, they are putting farther and farther when they are getting older. This is a condition we call presbyopia. And I'm going to simulate to you a real example. Imagine these letters, and these letters are at distance, so an old person, they can really see it. And what's happened when this person is putting closer and closer? It's closer and closer, closer and closer, and they are very blurred, they cannot read. So that's the reason he's trying just to put farther and farther, because they get a blurred condition. I can tell you that we are using this instrument really to try to obtain solutions to correct for presbyopia. So people that they cannot really accommodate, they cannot read near, they can do more properly. There is many other conditions, and I'm going to show you another condition that is very devastating. It's a condition called cataract. For everybody, basically everybody, when they get older, one of the lenses of the eye, the crystalline lens, is getting cloudy. And then what's happened? They can see nothing. How a cataract person is seeing? It's here. So this is an example of an image in a person with cataract. And you can say, what is this? Well, in fact, if there is a lot of cataract, there is so much scatter of light that there is no vision. This person can see nothing. The solution? Well, there is a very good solution, is to have a surgery to remove the natural lens that is cloudy and to implant this type of lenses. They are called intraocular lenses. When this person are with these intraocular lenses, by the way, we're using our instrument to design new type, improved type of these intraocular lenses. Many people in the world, they are having the lenses that we are designing here. What is the vision then? Something like this, before and after the surgery. They can see nothing. They can see practically the same as when they were young. Many other cases of situation that you can use this instrument to really simulate how other people are seeing. What is their interest? Well, it's a lot of fun because we can understand how different people are seeing. You can put in your boots of your grandfather or your neighbor. But what is also important for us, we are using these instruments to really obtain, to design, to invent new solutions to have people seeing better. So it's not only fun, I think it's practical, and we are really caring about these people's vision.